All right, so in this video, we're going to talk about how to write electron configurations. Now, electron configuration is essentially, it's like a shorthand of the orbital diagrams. All right, and so I'm going to start off with the orbital diagram so that you can see exactly, so we could review how we draw orbital diagrams. And then from the orbital diagram, we're going to determine the electron configurations. Okay, and as I said, electron configuration is just a shorthand version of the orbital diagram. All right, so let's kind of start off writing the orbital diagram for the atom of carbon. So let's start with carbon. Carbon has 6 protons. Let's assume this is neutral, and so it also has 6 electrons. So let's go ahead and fill this up accordingly. All right, so we have 1, 2, 3, 4, 5, 6. Now, what is the electron configuration? Now, as I said, electron configuration is just a shorthand form of this. And so what it consists of, the electron configurations consists of the subshell, consists of the shell, the subshell, and how many electrons are in that subshell. Okay. And so, like, for example, we have electrons here. So I'm going to write 1s. How many electrons are in that 1s? Well, there is 1, 2. To show this, we'll write 2 as a superscript. Okay. Then after you're done with the 1s, then we move on to the 2s. So I'm going to write 2s. How many electrons do I have in the 2s? Well, I have 2 of them. So as a superscript, I'm going to write 2. Okay. After that, then I'm going to write 2p. Okay. How many electrons do I have in the 2p? Well, I have 1, 2. I have 2 of them. Then so I'm going to write that as a superscript as well. All right. And so just to make this clear, what's kind of going on is that you have these numbers here represents your shells. All right. These letters represents the subshells that the electrons occupy, and you're only going to write the ones that you have electrons that are occupied by electrons. Okay. If it's not occupied by electrons, we don't write them at all. And then we have the superscripts, which represent the number of electrons that reside within each of these orbitals. Okay. And so that's how we write electron configuration. That's how we could derive the electron configuration from the orbital diagrams. Let's do another example. So let's look at the atom of sodium, right? So sodium is Na. It has the atomic number 11. So thus it has, if it's neutral, it has 11 electrons as well. So let's go ahead and draw out the orbital diagram. We have 1, 2, 3, 4, 5, 6. That's against the rules. All right. Remember, we have to separate them out first. 6, 7, 8, 9, 10. Even though it doesn't really kind of make a difference at the end of the day, but let's always draw these right? And then we have 11. Okay, so here are 11 electrons. And so now from the orbital diagram, we're going to create, or we're going to write out our electron configuration. So our first set here, we have 1s. How many electrons we have in here? Well, we have 2 of them. Okay. Then we have our 2s. How many electrons we have here? Well, we got 2 of them. Okay. Then we have our 2p. How many electrons do we have in there? All of them. There are 6. And then we have our 3s. How many electrons do you have in there? It's 1. Okay. Now, another way you could kind of double check yourself is that if you add up, or you take the sum of all our superscripts, it should equal to the number of electrons that we have, right? So 2 plus, I'll highlight this. So we have 2 plus 2 plus 6 plus 1 should give you 11. All right, which looks like this number here. All right, so if you see that, you notice that, then there's a good chance that you did this correctly. All right. And let's just kind of go through one more example of writing electric configurations. So let's say we're going to write the electric configuration for the atom of cobalt. All right. Cobalt has the atomic number 27. All right. So which means it has 27 electrons if the cobalt is neutral. In this case, cobalt is neutral. So let's go ahead and draw out the orbital diagram. We got 1, 2, 3, 4, 5, 6. Oh, nope, that's wrong. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. All right, so here, this is the orbital diagram for the atom of cobalt. Okay, so now let's write out the electric configuration. Well, we got 1s, 2, 2s, we got 2 of them here. 2p, we got 6 of them. 3s, we got 2 of them. 3p is our next step. We got 6 of them. 4s, all right, there's 2 of them. And then we got 3d. How many do we have? Well, we got 2, 4, 5, 6, 7. So 3d7. So this will be the electric configuration for cobalt. All right. So now, that's one way of doing it. I mean, I think in my personal opinion, you know, drawing the orbital diagram first and then writing the electric configuration is probably the longer way of kind of figuring this out. Now, another way that you can figure out the electron configuration is just simply by looking at the periodic table. All right, and so let me show you exactly what I mean by that. So here's a periodic table that's separated by each of the subshells, okay? And each of the subshells is kind of color coded for you so that you know you can see exactly where they are. All right, and so let me just kind of explain this so that we could kind of see what's going on. So the numbers that you see here, once again, these are your shells, your shell numbers or your energy levels. All right, and then next to it is your subshells. All right, now the way that you read this, you kind of want to read it like it's a book. All right, and if you want to try to figure out the electric configurations of something, you'll take out the periodic table, which, you know, I'm expecting for you guys to be able to do. You'll take out the periodic table, and then by reading the periodic table, you should be able to say, okay, this is the electric configuration of a particular atom. Okay, and so let me just kind of show you exactly what I'm talking about here. So like, for example, let's say if I wanted to write the electric configuration of the atom of boron. Okay, so when you look at this periodic table, and I only have this so that way you could kind of see what's going on. Boron is here. All right, so I'm writing boron where you will find it on the periodic table. Okay, so this is where the atom of boron, and I want to write the electric configuration of this. So when you write the electric configuration of this and you're looking at the periodic table, as I said, you want to read it like it's a book. When you're reading a book, right, you typically you start at the top left, right, and you read the words all the way to the right. Once you're done with that row, then you move on to the next row and you start at the very left and you read it all the way to the right. So the same thing here with the electric configurations. All right, you want to start at the very top of the periodic table and you want to read all the way to the right. Once you're done at the very end of the periodic table, then you move on to the second row, starting from the left, and you read all the way to the right. Now you keep on doing this until you get to the element of question. Okay, and so in this case, since we're trying to get to boron, all right, we need to we're going to start from the very top, and you're going to read it all the way all the way through until we get to boron. Okay, so what I mean by the very top, so look, we'll start at the very first row. All right, your very first row is your 1s. How many 1s's do we have? Well, let's count all the way through. We have 1, 2, 1s, 2. All right, we're done with the first row. Now let's move on to the second row. When we move to the second row, what we first come across is our 2s. All right, 2s. how many 2s's do I have? Well, I have 1, 2. So I have two 2s's. Then I'm gonna continue to move to the right, and then if you see here, I reach to the 2p. Remember, we're trying to get to boron. So here's my boron. If you notice, my boron is in my first slot in the p, right? And so it's going to be simply 2p1. All right, and so this is the electron configuration of boron. Now, if you were to draw the orbital diagram, you see it's the exact same way, but instead of doing all that, we're just going to use a periodic table to figure this out. All right, let's do another example. All right, so let's use one that we did earlier, so that way you can kind of see how the orbital diagrams kind of relate to this periodic table, trying to find the electron configuration. All right, so let's just say we're looking at sodium, right? And let's find the electric configuration of sodium. We know that sodium has 11 electrons, and sodium actually resides here. All right, so I'm right here on the periodic table so I can see exactly where sodium's at. So that way, when I start at the very top, I will have to just read the periodic table until I get to sodium. Okay, so as I said before, you start at the very, very top. All right, so we have 1s. All right, how many 1s's do I have? I have 1, move all the way to the right, and 2. That's my second 1s. Okay, once you're done with that row, then you move on to the second row. What do we have? 2s. How many 2s's do we have? We have 1, 2. So I have 2s's. And then I'll move all the way to the right, then I'll get to 2p. How many 2p's do I have? I have 1, 2, 3, 4, 5, 6. Remember how I said the p subshell can only have 6 electrons. There's your 6. All right, so I'm done with that row. Now I'm gonna move on to my third row. So I have 3s. All right, remember we're only going to sodium, and sodium is in that first box. So it's 3s1. So just like we said before. So it's 1s2, 2s2, 2p6, 3s1. This is the electron configuration of sodium. All right, let's do another one. All right, so let's look at the element of manganese. All right, manganese has an atomic number of 25. So it has 25 electrons when it's neutral. All right, manganese, it's right here on this periodic table. So we're going to manganese. So just like always, we'll start from the very top and then we'll move on. And so essentially is this, you know, the further to the bottom right, or the further to the bottom really, the atom of question for the electric configuration, the longer this gets. You know, it's like the difference of reading a 2-page storybook, a children's storybook, versus reading someone's dissertation. You know, someone's dissertation is like writing an electric configuration that's like 118, 100, 20 something, whatever the case is. I mean, if you look at a periodic table of the 2021 periodic table, that's like 126 atoms. Versus a children's story is like, looking at electric configuration that only has, 9 electrons. So the more electrons you have, the longer the configuration becomes. But as long as you follow this process of reading the periodic table left to right, next row, left to right, next row, left to right, you'll most likely get this right. Okay, as long as you kind of just follow the rules here. All right, so starting from the top, we got 1s. How many 1s's? 1, 2. Okay, next row, we have 2s. How many 2s's do we have? 1, 2. Okay, we're moving on to the next part of the second row. Then we have 2p. How many 2p's do we have? I'm right, 2p. How many 2p's do we have? We have 1, 2, 3, 4, 5, 6. Okay. Moving on, then we're going to the 3s. How many 3s's do we have? 1, 2. Going across the row, we got 3p. How many 3p's do we have? 1, 2, 3, 4, 5, 6. After you're done with the 3p, then we move on to the 4s. How many 4s's do we have? 1, 2. Okay. Now, when we're going across and we're moving across the row, we hit the 3D. All right, so make sure you kind of pay attention to this. When we get to the D block, okay, and this is just one of those things that you're just gonna have to memorize. All right, when you get to the D block starts the energy, or the sub notation is one less than the period that you're in, or the row that you're in. So we're in the fourth row here, but the D starts in 3. All right, so we are 3D here, and we're going to count up to manganese. So it's 1, 2, 3, 4, 5. So in this case, it's going to be 3D5. So the full electron configuration for manganese is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. So now I'm going to show you the shortcut to the shortcut, right? So electron configuration is like the shortcut to the orbital diagrams. Now there's even a shorter way to write these electron configurations, and we typically call them what we call the noble gas configuration. All right. And so it's just using the noble gases to help write these electron configurations a little bit shorter. Okay. And so let me show you what I mean by that, and an example, and a couple examples of these. All right. So like, for example, let's revisit sodium. Sodium is going to be popular today. All right. So here's sodium. Now the electron configuration for sodium, like we mentioned before, it's 1s2. So here's your 1s. So 1s here, and reading all, it's all right for the 1s here. Then we have the next part is your 2s, and there's 2 of them, 2s2. We're going to read this all the way to the right. 1, 2, 3, 4, 5, 6. So 2p6, that's your p block. And then we have finally 3s1. So this is the electric configuration for sodium. Now, when it comes to writing the noble gas configuration for sodium, what you will do is, the name of the game for this one is really called substitution. All right. And so you're going to choose the noble gas that comes right before the element of question. Now, recall the noble gases are all in the last column of the periodic table. So row or column 18 all consist of your noble gases. All right. And so you're going to choose the noble gas that comes right before sodium. All right, so your noble gases, you have helium, neon, argon, krypton, xenon, radon. The one that comes right before sodium will be neon. All right, and so what I'm going to do, I'm going to write in brackets neon. Okay, so what does this mean? Well, as I said, you're substituting. All right. When you write out the brackets neon, essentially what you're doing is that you are summarizing the electric configuration of neon into this bracket here. And the electric configuration of neon is 1s2, 2s2, 2p6. All right. That's the configuration of neon. And so then we just substitute all that for this element here, for this noble gas. All right, and then you just write out what's left, and what's left is this 3s2. So I'm gonna write, 3s1, and so then I'm gonna write 3s1 on the side here. Okay, now a couple of things, or actually one important rule with this, that the only thing that you could put in the bracket are noble gases. All right, anything in this column here. All right, you cannot have any other element other than the noble gases, and the noble gases are the only one that could go in the brackets here. And then remember, the noble gas basically substitutes from the actual electric configuration, its electric configuration from whatever electric configuration of the atom that you're looking at. All right. So let's look at another example. All right, kind of erase all this, and so we could see exactly what I'm talking about. All right. So let's say that we're going to write the electric configuration for the atom of bromine. All right, so bromine has 35 electrons. I'm gonna write it twice. I'm gonna show you the longhand, and then I'm gonna show you the noble gas configuration. Now bromine resides here, is to the left of krypton. Okay, and so let's go ahead and write this out. So we'll start with your 1s, your 1s here. How many 1s's do we have? Well, we got 2 of them. We move down the row, 2s, we got 2 of those. Then we continue down the row. So 2p, 1, 2, 3, 4, 5, 6. So we got 2p6. Next row, 3s. How many 3s? We got 2 of them. All right, down this row here, we got 3p. How many 3p's? 1, 2, 3, 4, 5, 6. All right, moving down the row, we got 4s. How many? 1, 2. All right, remember the row that D starts on is always one less than the row that you're really on. So it's 3D. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we're moving on to 4P. And how many? 1, 2, 3, 4, 5. 4P5. Okay, great. So now that we have that, all right, so now we need to figure out the noble gas configuration for bromine. All right, so remember, you choose the noble gas that comes right before bromine. And so if bromine is here, the noble gas that comes right before bromine will be argon. So then we're going to write argon in brackets. All right, and remember, this substitutes the the configuration of that noble gas. So I'm going to substitute the noble gas, this noble gas bracket here with its configuration. And if you look at its configuration is 1s2, 2s2, 2p6, 3s2, 3p6. That's the configuration for argon. And then so all I have to do is just write out what's left. All right, and so what's left is 4s2, 3d10, 4p5. Now, another way that you could look at this, just straight by looking at the periodic table without having to write the long form first and then trying to figure out the shorthand term. All right, and so if you notice, bromine is here, right? Actually, let me erase a couple of things so that way it's clearer. All right, so once again, I said bromine's here, right? When you write out the configuration when you write the argon, basically you covered the first 3 rows completely. All right, everything up to that noble gas, it's been substituted just by writing that noble gas. And then all you have to do is just start on the row that the element in question is on. Okay, and so now I'm going to start my 4th row because bromine is in the 4th row. So I will say 4s2, just like here, 3d10, which is right here, and then 4p4. And so that's how that works. Okay, so let's do an example of what I'm talking about, and hopefully it becomes clear to you. All right, so let's just say, and I'm just erasing a bunch of stuff. All right, let's say that we're going to write the electron configuration, the noble gas configuration. We're going to go big on this one. All right, not too big, but big. Let's look at antimony. All right, so antimony has the atomic, the chemical symbol SB. It's number 51, and it's about here. All right, here it is. Here's antimony. And so we're going to write out the noble gas configuration. I'm only going to write the noble gas configuration. I'm not going to go the longhand first. So I'm going to look at the noble gas that comes right before antimony, which in this case is krypton. So in parentheses, I'm going to write krypton. So this covers everything prior to krypton. So I don't have to really write out anything else. All I have to do is just start in the row that my antimony is in. All right. And so it's in the 5th row. So if it's in the 5th row, we'll start off with our S, 5S. How many? 1, 2. Here we're in the D subshell. Remember, it's always one shell less. So it's 4D. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4D10. And then we're going to go to your 5Ps here. And we're counting up to antimony. 1, 2, 3. So 5p3. So this is the way that you write the shorthand or the noble gas configuration of elements.